Every day, more than 100 million barrels of crude oil begin a journey that quietly powers the modern world. That journey begins thousands of meters beneath the Earth's surface, hidden inside ancient layers of rock. This isn't just a pool of liquid. It's a natural reservoir created over millions of years. Hidden inside that single drop are thousands of different hydrocarbon molecules. Some molecules are light and simple. Others are large, heavy, and incredibly complex. Together, they create one of the most chemically complex natural materials found on Earth. Yet despite everything hidden inside it, this crude oil cannot be used directly as fuel. Before it can power anything, it must first pass through an extraordinary industrial process. Ahead lies one of the most complex industrial facilities ever built. This is where our single drop of crude oil begins its transformation into the products that shape modern life. Every journey through the refinery begins in enormous storage tanks designed to safely hold millions of liters of crude oil. Our single drop joins millions of others as it begins flowing into the refinery's pipeline network. Moving millions of liters every day requires powerful pumps capable of generating a continuous and carefully controlled flow. Inside the pump, the spinning impeller converts mechanical energy into pressure, pushing the crude oil through the refinery. Along the way, sensors continuously measure flow, pressure, and temperature to keep the entire process under precise control. Before entering the furnace, the crude oil first recovers heat from products that have already completed part of the refining process. Heat naturally flows from the hotter fluid to the cooler crude oil without the two streams ever mixing. By recycling heat that would otherwise be wasted, the refinery dramatically reduces its overall energy consumption. After passing through multiple heat exchangers, the crude oil is now far warmer than when it first entered the refinery. But reaching the distillation tower requires one final step. The crude oil must first pass through an enormous furnace where temperatures climb to nearly 400 degrees Celsius. Before separation can begin, the crude oil enters a massive furnace where it is heated to nearly 400 degrees Celsius. As the temperature rises, the crude oil absorbs enormous amounts of heat while remaining under carefully controlled conditions. Inside the hot crude oil, the lightest hydrocarbon molecules begin turning into vapor first. Heavier molecules require much higher temperatures, so they remain liquid while the lighter fractions become vapor. The goal isn't to burn the crude oil. It's simply to prepare it for one of the refinery's most important processes. Every degree of temperature is carefully controlled to maximize separation while preventing unwanted chemical reactions. Leaving the furnace, the crude oil is now a fast-moving mixture of hot liquid and vapor. Ahead stands the tallest and most recognizable structure in the refinery, the atmospheric distillation column. Hidden inside this giant steel tower is a carefully engineered temperature gradient that does all the work. In the next stage, thousands of hydrocarbon molecules will begin separating naturally simply because each one boils at a different temperature. As the heated crude oil enters the flash zone, the pressure suddenly drops, and the lightest hydrocarbons instantly become vapor. Instantly, the tower becomes filled with rising vapor and descending liquid, both moving continuously in opposite directions. Inside the tower, dozens of trays slow the vapor, giving heat and mass time to transfer between vapor and liquid. Every bubble increases the contact between vapor and liquid, making the separation process more efficient. The hottest part of the tower remains at the bottom, while the temperature gradually decreases toward the top. As vapor rises into cooler regions, different hydrocarbons condense at different heights according to their boiling points. The lightest molecules travel almost to the top, while heavier fractions settle much lower inside the tower. Side outlets continuously collect each fraction without interrupting the separation happening inside the column. Within minutes, one stream of crude oil has become many valuable products, each separated using nothing more than carefully controlled heat and physics. But separation is only the beginning. Many of these products still need to be transformed before they're ready for everyday use. Although the distillation tower separates crude oil into different fractions, it cannot create more gasoline than nature originally provided. Most of the remaining hydrocarbons are simply too large and too heavy for modern engines. Instead of wasting these heavy fractions, engineers found a way to transform them into valuable fuels. This enormous system is called a fluid catalytic cracking unit, one of the most important machines in the entire refinery. Inside the reactor, billions of microscopic catalyst particles behave almost like a boiling liquid. Each catalyst particle provides an active surface where heavy hydrocarbon molecules begin to break apart. Long carbon chains split into several smaller molecules in just a matter of seconds. Millions of these reactions happen simultaneously, transforming heavy oil into lighter, more valuable products. The newly formed lighter hydrocarbons separate from the catalyst and continue through the refining process. In only a few seconds, chemistry has transformed molecules that were once too heavy into fuels that power millions of vehicles every day. Although the fuel is now much lighter, it still contains impurities that must be removed before it reaches the outside world. One of the most important impurities is sulfur, naturally present in crude oil from the moment it formed underground. To remove these impurities, the refinery sends the fuel into a hydrotreating reactor, operating under high pressure and temperature. Inside the reactor, hydrogen mixes with the fuel, as both pass through millions of catalyst pellets. On the catalyst surface, hydrogen reacts with sulfur-containing molecules, gently separating the sulfur from the fuel. Once released, the sulfur immediately combines with hydrogen, forming hydrogen sulfide gas that can be separated from the fuel. While the sulfur leaves the reactor as gas, the cleaned fuel continues forward through the catalyst bed. Millions of these reactions happen every second, quietly removing impurities from every drop of fuel. By the time the fuel leaves the reactor, its chemistry has changed in ways that are completely invisible to the human eye. Cleaner fuel now continues through the refinery, one step closer to becoming the gasoline, diesel, and jet fuel used around the world. Several different fuel streams now arrive from across the refinery, each with its own unique properties. Instead of filling a tank directly, every stream first passes through an automated blending system. Every valve adjusts continuously, ensuring each component enters the blend in exactly the right proportion. The blended fuel enters a large mixing tank where carefully designed internal flow patterns ensure complete uniformity. Inside the tank, every drop becomes part of a single uniform fuel mixture. Specialized additives are then introduced to improve performance, protect engines, and extend fuel stability. Although the additives represent only a tiny fraction of the final fuel, they have a significant impact on performance. Inline analyzers continuously verify that the finished fuel meets strict quality specifications. Only after every specification has been confirmed is the fuel allowed to move into final storage. After an extraordinary journey through heat, pressure, and chemistry, our fuel is finally ready to leave the refinery. The refinery may have finished its work, but the journey of our fuel is only beginning. For many products, the first destination is a network of high-pressure transmission pipelines. Powerful booster pumps keep the fuel moving over hundreds of kilometers without interruption. Along the route, automated valves and monitoring systems continuously protect the pipeline network. Eventually, the fuel reaches a distribution terminal where it can be sent in many different directions. Automated loading systems measure every transfer with remarkable precision before fuel leaves the terminal. Some of the fuel continues toward airports, where every flight depends on carefully refined jet fuel. Other products travel to cities where they become the gasoline and diesel used every day. Every destination begins with the same journey from one barrel of crude oil to a precisely engineered fuel. Yet fuel is only part of the story. Many molecules from that original barrel will never be burned at all. Fuel is only one destination. Many hydrocarbon molecules leave the refinery on a completely different path. Here, selected hydrocarbons become the basic building blocks used to manufacture thousands of everyday materials. These molecules become the starting point for plastics, synthetic fibers, rubber, and countless industrial materials. Those materials eventually become products found in homes, hospitals, factories, and vehicles around the world. Each product may look completely different, yet they all trace their origins back to the same barrel of crude oil. Behind every one of these products lies an enormous network of engineering systems working together with remarkable precision. Every hour, every day, refineries around the world repeat this process on an extraordinary scale. Millions of barrels arrive as crude oil, and millions of carefully engineered products leave behind. Our journey began with a single drop of crude oil hidden deep beneath the earth, and along the way it revealed one of the most complex engineering systems ever built, quietly transforming a natural resource into the fuels and materials that shape modern civilization.